So, I haven't recorded anything in a while because I've been rather busy, and because, frankly, it's kind of a pain to record, and because my, micro SD card that I record all this stuff on died, and is still being RMA'd, and I don't have a ton of space on the internal storage of my phone to record these onto. I also lost a decent amount of footage when that card died, but Google Photos backed up a lot of it, so at least I have that. But I figured I should record this because I've actually been working on this for a little while, without any documentation, and I haven't recorded anything in a while, so I might as well record something. So this is what I've been working on. It is a, Arduino dot matrix clock. This is just a cheap Arduino Nano, from AliExpress, cost about $2. There's a little, DS1307 RTC module, where the battery holder fell off, like, right away, because it was poorly soldered, because the person who soldered it didn't know what they were doing, and I could have soldered it back on, but it was surface mount, and I probably would have needed a hot air gun if I wanted to do it properly, which is probably why it wasn't soldered on properly to begin with. Because of the way it was designed, I don't have it anymore, I threw it out. So I just soldered on a couple of wires, and then there's the battery there, and it's in heat shrink tubing, which kind of shrunk, but it didn't shrink super well, so I just wrapped it in some Scotch tape. Probably should have wrapped it in electrical tape, but that was what I had. That was the tape that was closest to me at the time, and I didn't feel like coming down here for some electrical tape. And it seems to be working fine. This whole project cost about $5. The dot matrix here was $3. The Arduino was $2. This was 50 cents. And then everything else I had on hand, which was just, I 3D printed this case, which didn't print especially well, and isn't deep enough, and it isn't going to be on breadboard forever, which is kind of what this video is about. It's about this, which is I'm working on. This is just blue tack, I guess you could call it, or tacking putty, I don't know. It's that, like, putty you use to hold on posters. Blue tack's a big brand here in America, but I don't know if everyone knows what that is. So I printed out a scale model of the Arduino Nano, just because I wanted to make sure I had everything spaced right. I have a lot of pin headers, many of which are buried under here, but you can't really see it because this doesn't want to focus on this, and this is very shiny, but there's lots of pins down here that I'm going to solder. And then this is about the exact same height as the case, so that'll just make everything a lot cleaner, whereas this is too tall, and I won't have nearly as many wires down here, though the two control buttons, because this clock is running code programmed by Nick, which I'll put a link to his site. I just took his code because I didn't feel like programming it from scratch. Though I may make some modifications to just create a little quick switch for brightness, because this, I like it on the dimmest brightness most of the time, but sometimes I want to make it brighter, and it's buried in the menu, and anyway, or I might do a photo resistor. I may try to program it so I have a photo resistor mounted somewhere on here, and then it takes readings from that and controls the brightness based on ambient light in the room. But these are the two buttons to control the I guess you would call it an operating system, the UI, the menu system, whatever you want to call it on here. And there's just two buttons on that breadboard back there, but I'm going to have it on a daughter board that's going to be mounted here in the updated. I'm going to reprint this because this didn't print especially well, and again, it's not deep enough. I'm going to put a couple. Tripod almost fell over. I'm going to put a couple holes for these buttons, and they're just going to fit right there. And it's going to be connected with 3 wires, ground, and then the 2 digital pins for the button, just with a couple of wires over to the main board. And of course, these 5 wires here, I'm going to get shorter ones that are female to female. That have female headers on both ends, because this has a male header on it, and I'm going to put a male header like this, but 5 pin over on there for the 5 pins of this to go onto this board. And again, I have the whole board laid out, so I'll show that eventually, but yeah, this is actually a really cool project. The operating systems, again, I'm just going to keep calling it that, even though it's not technically one. The operating system that Nick wrote is actually really great. It's super easy to navigate, assuming you didn't put the buttons in a stupid place on the breadboard, which is my fault, just because this is to make sure everything worked before I went and went and transferred it to Perfboard. It seems to keep somewhat accurate time. Though there have been some complaints made on Nick's blog about it not keeping super accurate time, and apparently that can be fixed by using a DS13 something. I don't know. Again, I'm going to put a link to Nick's blog where you can download the code and look at those comments. I don't know the number for that. I just know this is a DS1307. It might be a DS1332 or a DS1331, I think, is what they want you to replace it with if you want it to keep better time. And those are about $1. So they're twice the price of this, but that's only 50 cents more. So I may actually buy one of those, depending on how well this keeps time in the long term, but that is just a drop-in replacement because it uses the same communication protocol, which I believe is SPI. I believe these are SPI devices. In fact, I can say with reasonable certainty they're SPI devices. Maybe they're I2C. I don't know. They have SDA and the other one. I don't know. I should know, but I'm kind of blanking on it right now, and then I also kind of don't have a super extensive knowledge of things like that. But anyways, it's a drop-in replacement, same communication protocol, same address, because you need to tell the software the address of these things, but apparently both of those modules use the same address, so you don't need to change that. Basically, I should have no reason to update the software, and I should just be able to pull this one out of its socket, because I will socket this one on here, probably round here-ish, and then I'll just drop that in. I should just be able to socket the new one in if this one proves to be inaccurate. Yeah. Here's the 4-pin socket. 2 pins for power and 2 pins for data. And these are just really cheap pin sockets I bought on eBay. I think I got a big pack of them that I've just been cutting down to size, both male and female, for about $1. But that is all for now. I'm going to make the board, and I'll probably record once I get the board made.